Hello and welcome to Lesson 2 in Unit 2A. This is right angle trigonometry. This lesson, Introduction to Trigonometry. We're going to start with a little bit of labeling. You'll notice that I've got some triangles drawn here and they are filled out. So what I'd like you to do is copy those down and then we're going to talk through them just a little bit. So hit pause here, copy this down into your notebook or in your blank note. When you come back, we'll talk through it. All right, you're back. You've got them copied. Let's have a look at this guy here first. When we're talking about trigonometry, interestingly enough, we're talking about properties of really any triangle, but we're going to focus on right angle triangles to start because there's a certain set of tools that we can use to determine missing sides and missing angles in triangles that are different than the ones where we could use broadly with any triangle in the world. And it starts with this idea that we have a reference angle. So a reference angle is an angle that we're going to be using to orient ourselves inside the triangle. Now in this triangle here, in triangle A, B, C, I have chosen angle B to be our reference angle. Now we know that the hypotenuse is always the side that's going to be across from the right angle in a right angle triangle. The next side that I like to label on a triangle like this is going to be the side opposite. And what that means is where I've picked my reference angle here, angle B, the side that's across from it, we call that the opposite. And then the final side we call the adjacent. Again, we've got some new words coming at you here. Hypotenuse should be familiar. Opposite, you should maybe have used the word before, maybe not in the context of a triangle. And adjacent, also a regular old English word, but we use it mostly when we're talking about trigonometry. So what's interesting is take that same triangle, triangle ABC, and instead of making my reference angle angle B, this time I'm going to make my reference angle angle A. So some interesting things happen here. First is hypotenuse stays the same because it is still across from that 90 degree. So the hypotenuse in this particular case is still side little c. However, the opposite side of this triangle has changed to side little a, the side across from our reference angle, and that leaves us with our adjacent side as the side that is left. Adjacent really just means beside, actually. So if you think of this as our reference angle here, this angle is beside it, same as the hypotenuse. Okay, so this is the type of labeling we're going to do. I guess I should also say that when we're looking at these triangles, the corners, the vertices of a triangle, we're going to label those in capital letters. And then the sides across from those capital letters will be labeled in the lowercase same letter. So as I just finished saying, if this is angle capital A, across from it, side little a. If this is capital C, across from it, little c. And if this is capital B, across from it, side little b. And this is something that we always do just so we always know what sides we're talking about in right angle triangles. Okay. Now we're going to investigate the primary trigonometric ratios. So if you think about right angle triangles, you realize a couple of things. The first is that it always has a right angle, which is helpful. It's an easy way for us to identify what they are. But when we're talking about making comparisons between two right angle triangles that are similar, and this is what's important, if you look at these triangles, we know here that they are similar. I know that these two triangles are similar because they have that 90-degree angle locked down. We've been told that these two angles here, and we're also talking about this big version over here, those angles are 53 degrees. It means that no matter what these angles here at the top are, they're all going to be the same, which means that these three triangles are similar. And there's certain things we can do with that. The goal here is to make comparisons between specific sides of these right angle triangles to see that they are, I guess to reinforce that they are indeed similar. So let's check it out. The first side here that we're going to set up is the opposite side over the hypotenuse. Now again, just to recap that, maybe I'll just erase these ones here so that we can see how I would label it in real time. So given a right angle triangle, the first thing I like to label is the hypotenuse, and that's this side over here. It's across, it's across from my 90 degrees, so that makes sense. The next side I like to label is, knowing that this is my reference angle, the side across from it is going to be the opposite, leaving us with the only remaining side to be the adjacent side. Now if I'm going to write the value of the opposite side, which is 1.5, over the value of the hypotenuse, that's 1.5 over 2.5. When I do that division, I end up with 0.6. So far so good, no problem at all. Let's run down the line and do that same setup for all three triangles. So again, if we're going to do our labeling here, I know that this would be my hypotenuse, since it's across from my 90, across from my reference angle will be my opposite, and adjacent will be the one that's left. And if I'm doing opposite over hypotenuse, that will be 3.0 over 5.0, I think. Yep. And when we do that little bit of mathematics, that's 3 divided by 5. That comes out to be 0.6. All right, we're doing great so far. And let's do that last triangle as well. Again, let's reinforce that labeling that we were doing. So from our reference angle, we know that the side across from it will be the opposite. We know that the side across from the 90 will be the hypotenuse, and that leaves us with the adjacent hanging out down here. So there's adjacent. If we're going to be writing the opposite side over the hypotenuse, 3.75 over 6.25, and when we do that math in our calculator, 3.75 divided by 6.25, we end up with 0.6, as you might expect. Now, I'm not going to go through and do all of these remaining ratios. This is a really great exercise when we're in class actually doing it, and it's lots of sort of fun to sort of get people engaged and working with their calculators, but we're not going to spend time on it. Suffice to say that the thing I'd like to point out is the comparisons that we're making in these triangles. We're comparing specific sides. So we're saying opposite side divided by hypotenuse. That was the one that we did first. And then we're going to do, in the second set, adjacent over hypotenuse, checking what that particular value is. And lastly, we're going to be doing opposite over adjacent. So we're looking at 3 specific ratios. And what's interesting about that is those are the first 3 that we look at, and that's why we call them the primary trig ratios, because there are actually lots of different ways that we could compare these. For example, here we did opposite over hypotenuse, but we didn't do hypotenuse over opposite. We did adjacent over hypotenuse, but we didn't do hypotenuse over adjacent. And we did opposite over adjacent, but we didn't do adjacent over opposite. So these are just the first 3 possible ways that you can compare these sides. And in right angle triangles, we call those 3 specific organizations of ratio comparisons by specific names. And I've got them highlighted over here at the side. So what we've got is, when we're talking about opposite sides being divided by hypotenuse, we call that the sine ratio. So sine of a given reference angle would equal the opposite side over the hypotenuse. The one that we didn't look at, or one of the 2 we didn't look at, is when we compare the adjacent side and divide it by the hypotenuse. We call that cosine of a certain reference angle. And lastly, we have the comparison of the opposite side divided by the adjacent side, and we call that the tangent ratio of a specific reference angle. So what we have here are 3 words that we need to remember, and it's the kind of thing you just have to work at. Sine always refers to the opposite over the hypotenuse, cosine always refers to the adjacent over the hypotenuse, and tangent always refers to the opposite over the adjacent. So what I'd like to do is, let's label this triangle. So here we have triangle ABC, and we are going to pick a reference angle. Now this section below us here, it wants to know what the sine of angle A is going to be. So it's giving us a clue. It's saying angle A should be our reference angle. So I'm just going to color that in. And from angle A, I want to label all 3 sides. Let's start with the one that we know most obviously, is across from our 90 degree. This is going to be the hypotenuse. Whoops, get out of here. That's going to be the hypotenuse. It's also going to have a little letter associated with it. So if this is capital B, recall that this would actually be side little b over here. Now from our reference angle A, the side across from it we call the opposite. And again, if we were going to give it a letter, that would be side little a, because we have a capital A over here in the corner. And last but not least, this would be the adjacent side, and it would carry side little c, since it is across from large C over here. So if we were being asked to organize the sine of angle A, we're being asked to provide the value for the opposite side over the hypotenuse. That's what sine is. So sine of angle A is equal to the opposite side over the hypotenuse. So let's copy those down. The opposite side in this case was the opposite was side little a, and we put that over the hypotenuse, which we had as side little b, I believe. Yep. So then the cosine of angle A will be equal to the adjacent side over the hypotenuse. So the adjacent side has a value of little c over the hypotenuse, which is little b. And last but not least, tangent. Tangent is going to be the opposite, tangent of angle A will be the opposite side, which is little a, over the adjacent side, which is little c. So I want you when you're looking at these things to remember that there are three particular parts to this that are variables. And I'm going to change up my colors. Actually, I'm going to change it to hot pink because it's super important. So let me just scooch over here, and I'm going to put this sort of referring to all three of these. These are all three variable equations. And the reason that I want you to remember that is because our tendency, and I'm as guilty of this as anybody else, is to say sine is opposite over hypotenuse. Cosine is da-da-da. But I don't want you to ever forget that the reason that we have opposite and hypotenuse and adjacent labeled properly is because we've selected a reference angle, which is also a variable. When we're talking about three variables, it's a reference angle, two sides, reference angle, two sides, reference angle, two sides. And all three of those represent values that ultimately we could find if we needed to using well, a variety of tools, but starting off we could use it by setting up a couple of different proportions and working it out. So we're going to stop this video here, and then we're going to come back and we're going to finish this last couple parts of it, and we're going to get you on your way working with the beginnings of trigonometry. So see you in part 2.